Now we will start with preparation of alcohols. Means how alcohols are prepared. There are several methods. First one is by hydrolysis of alkyl halides. Hydrolysis of alkyl halides. When alkyl halides are treated with aqueous sodium hydroxide, they form the alcohols. And for example, let's take example of this CH3 CH2Br. We are taking the ethyl bromide. This when treated with NaOH in the presence of water, they form CH3 CH2OH. This is your ethanol. Plus we will get NaBr. Second method which we are taking is by the hydration of alkenes. Hydration of alkenes when alkenes are treated with sulfuric acid, they form alkyl hydrogen sulfate, and which on hydrolysis will give the alcohols. So let's take example. This is your propylene. This when treated with sulfuric acid, we can write sulfuric acid like this. Here we know this will be positive, this will be negative, and we are going to get CH3CHO and this SO3H and CH3. This is isopropyl hydrogen sulfate. Isopropyl hydrogen sulfate. Now this when hydrolyzed HOH water, here we will get H on this side and OH on this side. We get CH3 CHOH CH3 with the formation of H2SO4. So this was by the hydration of alkenes. Besides this, the alkenes on the hydroboration and oxidation produces alcohols. Look how hydroboration, we say it hydroboration followed by oxidation of alkenes. This is your propylene. This will react with diborane B2H6 and we can write it like this, BS3. It is your borane. This is going to form CH3 CH2 CH2 whole thrice B. This will be tripropyl borane. And this tripropyl borane when it is treated with water plus H2SO4 plus H2O2, that is hydrogen peroxide, H2O2, and in the OH negative aqueous alkaline medium, they are going to form CH3, CH2, CH2OH. This is another method of preparing alcohols from alkenes. Besides this, alcohols can also be formed by hydrolysis of esters. Hydrolysis of esters. This is your ester. This when hydrolyzed, presence of acid, this water molecule will break from here and we get RC double bond O OH plus ROH. This is your alcohol. Similarly, by reducing aldehydes and ketones, by reduction of aldehydes and ketones. When aldehydes are reduced, we get primary alcohols. And when the ketones are reduced, this was in the presence of nickel catalyst. This is your secondary alcohol and this was a primary alcohol. And next is by reduction of the aldehydes and ketones by metal hydrides. Let's write CO compounds by metal hydrides. Look how we can use lithium aluminum hydride or sodium borohydride Na4. This should be in the presence, second step will be the hydrolysis in the presence of the acid. We will get C, H and OH. And now let's see the mechanism of this reaction. Mechanism is, first let's take the example of lithium aluminum hydride. In this, what will happen? This LiAlH4. This is like this. Li, this exists like this. Li plus and AlH4 negative. Now, the carbonyl group will be attacked by this. How? You know that property of the carbonyl group is that HAlH3 की presence में this one shift towards this side. And now we will get CHO negative AlH3 and further 3 molecules of this we are taking, and now you will get O Al negative. This will be hydrolyzed in the presence of the acid. We will will get 4 molecules of alcohol with aluminium hydroxide. This was the mechanism with the lithium aluminium hydride. Now let's take mechanism with the sodium borohydride. How this reaction will take place there. Let's take that example. Mechanism with sodium borohydride. This is your NaBH4. This exists like this, Na plus, H4 negative. Now carbonyl group, when comes in contact with this, you can write it like this, BH3H. This will be shifted to this side and this bond will be on here. CHO BH3 and this we will get H CH HO and whole 4 B, and this one hydrolyzed in the presence of acid, we get CH. Here you can write any group. This may be C or H, whatever. So this is the mechanism with the sodium borohydride. And in the next video I am showing other methods also.